Welcome to the unofficial Meraki demo channel and this video which will demonstrate to you how to build your own captive portal server that does device profiling and how to integrate that to your Meraki network. So our topics for today are the following. First of all, we will chat a little bit about what client profiling is, what is the use case, when would you like to use it, what you can achieve with it, and also at the same time show you the lab topology. So what kind of components did I use to build all this stuff? And after that, we will go to demo mode. And first of all, I will show you what does it look like when you operate this solution. So what does it look like when you have the finished product on your hands? And after that, we will also discuss a little bit about how to build it yourself. So where do you find the resources? How do you customize it? How do you tailor it for your own lab or demo environment? Or if you want to take something like this into production, of course, you could use the basic concepts to build something that is production ready. So to kick off the actual content, here is my lab topology that does device profiling. And the first topic I would like to discuss before even touching what these components are and why they are used is what is client device profiling. Client device profiling is a term for technology that identifies what type of client devices, so end user devices, connect to your network and can do some kind of differentiated access based on that information. On this diagram, you can see what I have used in my lab. I have used laptops to identify workstation type of devices, and then I have used iPhones, which I use to identify a bring your own device type of device. So the idea is that for laptops, I will give corporate access, which, well, in my lab doesn't really do much, but in theory, you could push things like firewall rules, traffic shaping rules, all sorts of either restrictions or enabling a wider set of access or a better quality of access for your enterprise or your corporate workstations. And then with the iPhone, what I try to catch is client devices that users have brought from their home, different sorts of mobile operating systems, Android devices, well, iPhones, iPads, um, or whatever exotic device they could have. Um, it could be even some kind of operating system that doesn't come to my mind right now. So the idea is that you differentiate these things and you provide them a different set of services. Now, how do we achieve this? We use components of the Cisco Meraki Cloud Managed solution to achieve this. And um, on a side note, uh, client device profiling is something that is included by default in the solution. So that is a feature of the Meraki MR access points already. Now, the idea behind this lab is that what if you want to run your own profiling algorithm? So what if you don't want to go with the default logic, you want to either customize it or you want to grab different sorts of devices which are not in the system before, you want to integrate that with some other backend logic to do some additional checks and so on. So how do you customize the, um, the profiling logic? So how I have achieved this, I have two locations on two separate internet connections. So I have here on my desk, I have my Meraki MR33 access point, which is connected to my um, Meraki Z3C teleworker device that has an LTE uplink, and they are the devices that you see on the left on the diagram. Then between my teleworker gateway and my data center, I have a so-called software-defined WAN link, which means it's a VPN technology that can do all sorts of fancy features with application load balancing and so on. And these two create the connectivity between my branch side and my data center. In my data center, what I have a VMware ESXi host. On it, I have a CentOS server. That server runs Node.js. On Node.js, I have a simple app that that provides the pages, the web pages, the captive portal that is used in this lab. And then, of course, out on the internet, there is the Meraki Dashboard Cloud Management, which provides management and also monitoring for all of my networking devices. Now, let me show you, first of all, how this system operates. So to do that, I will show you what the experience is on my phone. So what you can see on the right is I have an SSH connection with PuTTY to my Node.js server. This is the logging screen, and then I can basically connect my iPhone as well, so that you can see live what is happening. Now let me move my camera a little bit so that you can see what I'm doing with my phone. Let's see if this works. So my phone is here. What I do is I open Wi-Fi, and then I will connect to my SSID. And let me just type my password. So I connect into my Wi-Fi, and after that you see a pop-up of the portal. So what I can do now is I can give, let's say that we have a user who is called test user, and their email is let's say no reply at icaram.net, and he agrees to the terms and conditions and registers. So you are now connected to the internet. Hooray! So ready. That's it. I'm online. I could browse. I could go to some address and so on. Now, let me take the camera back. Here you can also see my Z3C. And just change the layout quickly. Ta-da. So here you can see what happened on the network. So we got a new entry here. When I connected it, I got my test user iPhone. So this is a name that was generated for the device by my portal. And then they got a group policy of client BYOD. Now you see there also the laptop that I had on the right when I moved my camera. If you were really quick, you noticed a Lenovo with a black screen on it. That is this laptop, and I just did a quick check earlier with it, and you see that it got the corporate policy. So that's it. Basically, the devices are recognized by my portal and they are assigned a different policy. Now, how did I build this lab? Well, first of all, it's based on the Meraki Wi-Fi technology. I used templates in my lab. A configuration template is a way to unify Wi-Fi configuration or other configuration, in this example, Wi-Fi across a large number of branch sites. The idea here is that even though that when the user moves from one branch to another, they should be able to get the same type of services regardless of what branch they are in exactly then. So if I go to my template, I will be able to show you the group policies. So where did I, first of all, what does my SSID look like? So I created an SSID, the one that I connected to, that was called profiling portal. If I edit the settings here, what kind of settings did I make? Well, first of all, I gave it this lovely pre-shot key so that there is some security here, and then I created a splash page um, that is type or click through. So that's a setting I needed to do. And then I also set it to bridge mode. So the default is NAT mode. I don't want to do NAT at the access point. I just want to drop everything on my local LAN and process it there. So I just turned it into bridge mode. So that is everything I did in the SSID part. Now another setting I did on the Wi-Fi is configuring my splash page. So if I go to the wireless splash page menu, I select my SSID. It's pre-selected profiling portal. I actually told it to use a custom splash page, which is my CentOS image that is running on my data center. And you see, I can use the local IP address. So um, if I go back to the topology for a moment to discuss this, you see that I have the SD-WAN link between my branch side and my hub side. And I have that because I wanted to allow the access point to communicate with the server um, locally without needing to go over the internet. Now, if I wanted, I could have uh, just remove those two SD-WAN devices altogether and just expose my server to the internet one way or another, either using, for example, port forwarding on a firewall or something like that. So the access point could have communicated with the server also via the internet if I wanted to do that. But I just wanted to keep all the traffic local, so I created the SD-WAN link there. And going back to sharing mode, yes. So that is how I'm able to use the local address of the server here, even though they are in behind completely separate internet connections. And let's go to the group policies. So where are the group policies defined? They are defined here. Network-wide group policies, and as you see here, I have my two group policies, registered client corporate and registered client BYOD. In my lab, they are exactly the same because, well, I mean, I didn't really create anything, but as you see here, I can add different rules. For example, I want to add some custom firewall rules, or I could say that, well, I could create a default firewall rule set to block stuff, and then when you, for example, register with a corporate device, then you can also, well, bypass those rules and get a wider set of privileges or stuff like that. And also there's traffic shaping, so you can for example prioritize some kind of applications here, like let's say all VoIP and video conferencing applications and so on. So I could I could update this and say, okay, this is my corporate policy. So now this is applied to all the corporate clients. Actually, let's prioritize that. So let's set a better, yeah, now the policy makes sense. So that is the configuration on the Meraki side. You create your group policies, and you also create your SSID and give it a splash page. Now comes the fun part. So how did I create the portal? Well, the portal is uh, it's based on the Meraki APIs. I use two APIs. So I use the captive portal API, which creates the method to communicate with the splash page, and then I also um, use the dashboard API to send the commands to set the group policy for the clients. So dashboard API, as you see, is a REST JSON-based API, and here you can see all the endpoints that it supports. So the address to get the documentation is developer.cisco.com/Meraki. You don't need to log in or anything. The documentation is out there. Um, for example, for setting the group policies, there are multiple commands here. The command, the endpoint that I used is actually this one. So I pre-provision the clients. The idea is that I use this command because um, it allows my lab to be expanded to a use case where I would be able to pre-provision the client to multiple networks, even to networks where the client hasn't ever been. So the idea is that I could potentially, if the customer has 300 branches, just go and provision the client to 300 branches, no matter where they connect the first time. And if you want to try out all of these commands and you want to understand how to build your software, there's a try out button here. You can run it. There is, well, you see in some commands there is not much content there, but you can modify the well. Let's configure this command. You see, you can add an API key, and you can add some other information to run the command. For some commands, this tried out button works. For other more complicated, well, it's better to just use a tool like Postman. So you can export this documentation into Postman with Postman 2 form, and I realize my video is on top of the content right now, so I'll just hide that. So you see there you can export this to Postman, and you can well, run in that environment to try out the commands and so on. Now, if you want to run my server, where do you find it? And how do you run it yourself? Well, it's basically this link. So you can find it in GitHub. I will also put in the description of this video so that you can easily find it. If I just show you what is in there. So this is my GitHub, and you will see here the documentation. It's based on code made by a colleague of mine, but it has been adapted for this use case. So you can find it there. What does the code look like? It's basically here. So there is the whole profiling logic happens in these three files. So you will find a folder in there called routes, and it has the index.js. And here you will find a function called profile client. What it does is it basically checks for the user agent string uh, from coming from the HTTP request of the client. It checks for different parts there, and then you can also do some MAC address checks to further verify if the client is um, the user agent string says, or if it's something different. Now, will you do MAC address checks for Windows machines? Maybe, maybe not. Depends on how much control you have over what the users bring. For example, let's say that your corporate laptops are Lenovo's, then perhaps you only allow recent Lenovo OUIs and not, let's say, Android OUIs, which say that, which have a user agent string saying that they are Windows machines. And of course, this is a super simple algorithm for doing profiling. So this is something that obviously, if you wanted to run it in your own lab, or if you wanted to run it, to run something like this in production, you would have a more complicated profiling algorithm that would have more checks and would um, allow for more types of devices. So anyway, we classify here the device as something, and then what we do is we pass it on to the web page that is that you saw when I registered with my iPhone. So it has here a hidden input type called client type, and here is where the web page will receive the client, the profile information. Then what happens is that when the user submits this form, this information is passed on to the login logic, where again we check for the client type, and then we just check from the configuration file what is the correct policy ID to give to each type of devices. So Windows and Macs, let's say they are corporate devices, then Androids and iPhones are BYOD devices. And finally, what we do is we go to we use the Meraki dashboard API to run the commands and first of all find the network where the access point they connected to belongs to, and then just set the policy for that network. So that's all. I hope you liked this demo, and just please check the project and have fun using the Meraki APIs.